Hi, this is video log entry 136, and it's about 10 a.m. CST. I always say this at the beginning. I always say I've been busy. Of course, I'm busy. I'm a busy person. I have too many things to worry about, and way too many things. I have a banana. I'm eating a banana right now. So too many things. My brother and I are probably going to be collaborating, and we're going to be building a quote-unquote forum/blog website centered around STEM-oriented subjects. And yesterday I was looking at Golang, because apparently my brother likes Golang, and he just mainly due to, I think, Golang is really good due to its extended standard library. So I'm looking into it, and it happens I have basically all of the basics, the rudimentary standard library stuff that you would see in C, and some extended functionality pertaining to, let's see here. No. Where is it? Oh yeah, project. I have a lot of tabs open right now. So it seems like it has. Oh, cool! It has a lot of libraries, and I have this documentation page open. Just as a side reference, and I'm going to practice some of its syntax. And it seems, from what I can see, it seems pretty similar to C. I mean, it uses curly braces, I believe. One second. Oops. I have a file for Hello World already. Called my folder Go Practice. I'm using nvim right now, lazy vim actually. I thought I CD'd into. That was main.go, right? Yeah, so it looks pretty familiar to what I've seen before. Oh god, I hate it when lazy vim has these pop-ups that occur for different updates and whatnot. It's it's useful, but it sits there for longer than I'd like it to. So it's basically, it kind of reminds me of Python, at least when it comes to modules and then importing sets of functions. I don't know, I can't remember the difference between modules and I think modules are packages in this place. You can call it a library, and a library usually contains a bunch of files which contain a bunch of functions, or you can call them routines or whatever. I think that's basically how they segregate in this, but they call libraries packages, and then you can import different. I don't know, it's import FMT. I don't know what FMT stands for. I think it's just a formatting thing. So I have to look into that. And I'm also getting earphones today because I lost my case for my JLab Sports, and I got more expensive ones because there was a good sale over at Best Buy. I went to Target yesterday, and they had the same sale, but the sale was from the 15th to the 17th, but the sale over at Best Buy was today, or yesterday. I think it's a time span of a few days and whatnot, but so I got that, and I got 50% off on those, and they're delivering it to me today. I didn't feel like going to the Best Buy because there are no Best Buys near me, but good thing they have, delivering and whatnot. So, so that's an aside. But yeah, I'm learning Go right now. I'm not trying to overwhelm myself too much because I'm doing a lot of things in parallel, including a lot of adulting things and looking for jobs, and also looking at my physics interests. And I was looking at the Pauli exclusion principle earlier today, and the Pauli exclusion principle is meant for fermions. Fermions are not information carrying particles. I mean, they are information still, but they like to segregate information carrying particles from the particles that have mass. I think all fermions have mass, right? But there are some information carrying particles that have mass and some that don't. Photons are the information carrying particles, or bosons, and photons are bosons, and they have no mass, but there are information carrying particles that do, and that's, I think, the Z bosons, the Z, they call them Z naught or something, and then they have, is it Z negative and plus? I don't remember. And those they have mass. I think those are the only ones with mass for when it comes to the bosons. I don't think the Higgs boson has any mass because, well, I mean, that is actually the, I don't think so. That would seem contradictory. Yeah, so I'm kind of looking at I'm kind of delving more into the standard model because I was not really too familiar with it, and I decided to educate myself, and I wrote a nice little graph of the different kinds of particles, yeah, elementary particles, like the up and down quarks. They segregate between generations because the Gen 2 and Gen 3 tend to decay really quickly, so you don't really see them a lot in the universe because they happen to want to go to more stable states, and apparently those are not stable for whatever reason. I wouldn't know why. I forgot, they probably like emit some kind of like photon or a different, probably a photon, and then an electron, or it becomes an electron neutrino or whatever. I don't know all of the decay stuff, and you have to look at the Feynman diagrams and to see how what their current understanding of these different dynamics are. So I haven't looked at all that yet, but I've been enjoying myself, and they tend to actually segregate fermions between leptons and quarks. An example would be an electron being a lepton, and quarks would be up and down. Now, I actually don't know why. I think the reason why is because you have protons and neutrons, and protons tend to be 2 up and 1 down, and the neutrons are 2 down and 1 up. So I think that's probably the reason why they segregate those two, because they're bigger particles, are actually bigger than electrons that contain these quarks, and they're seen as building blocks for heavier particles, I guess. Now, I don't know why they're called quarks. I don't understand why they're called leptons, but they're probably named after people. I don't know. Yeah, anyways, I don't know the history as much as I'd like to, but I don't like the naming conventions. The naming conventions are a little bit silly, like the strange and the charm quarks is like, whatever. And then they have like the up and down, of course, and then another, it seems like most of the quarks are kind of silly. And they have like the tau quark and the bottom quark. I was like, okay, whatever. I'm not the one naming all this stuff. I want to take this stuff seriously, but when they have these silly names, it's just like, what are we, like kids in preschool or something? I don't know, man. It's just whatever. It's fine. I think it's interesting, and I'm just not going to worry about the naming conventions. If that's what they want to name it, then whatever. Yeah, so I was looking at that, and again, I was looking at the Pauli exclusion principle only pertaining to fermions because fermions are considered to be quote-unquote anti-symmetric. And anti-symmetric just means that if you have a state, a wave state, and you have, I don't know, like 2 particles that can be segregated into a wave state containing, so you can think of like a wave state with a superposition, and these superpositions can be separate particles, and these 2 particles are quote-unquote fermions. If you swap them, then it means they're a different state because these particles are supposed to be distinguished, like electrons and whatnot. So of course they can be distinguished in multiple ways, but if you distinguish I don't know, like if these are the same, like you can think of them as people or objects that have a uniqueness to them, right? You can think of them as like 0, 1, and I don't know, if you swap 1 and 0, obviously that means they're in a different state because they're individual, and you can think of it like that, because like 0, 1 does not equal 1, 0 in computer science. So I mean, that's a good way to see it. That's basically the Pauli exclusion principle from an information theory perspective. Whereas that's why they call it anti-symmetric. Whereas bosons are symmetric, so it doesn't matter how you distinguish them. They're the same. They just carry information. The information itself is the same as the other information particle carriers, of course, because they're just information. They kind of like, I don't know, you can think of like, again, the electric field. The electric field, if you have, an electron in the field and they have another electron in the field, they would be emitting light, like some kind of, that we can't see, of course, because they would have to know that they're there. So it does permeate throughout the electric field to tell that quote-unquote particle, this being a photon or whatever, that they're close to each other, or maybe too close to each other, they start repelling. Regardless, they have to know that they're there because there's still an imposition of a force on it. So the electron, for it to know that is it's kind of weird to think of it like this, but the electron has to know that there is a force being. That's why it's good to see it from a computer science perspective, and that's why I see it from the quote unquote non-terminal perspective, as a series of nodes with certain inputs and outputs, and of course you can think of it in one dimension, which is, I think I did the math wrong for that earlier. Yeah, I mean, I think I did the math wrong. And I was also thinking, it's like, there's only an input coming in from the non-terminal domain, from outside of what we can see, or from what even these, it's the imposition of information outside of it, but I don't think they talk to each other. Maybe they do, so I mean, that means you get a two-way street on three sides. So that means that's already 6 inputs and outputs, and then a +1 output onto the display of the display or the field. So that's how I think of it as, because again, it's a two-way street between all the other nodes, and yeah, so it's was like a 2n plus 1. I talked about this earlier. You have to think about the dimensions. Like, one dimension means that you're gonna have well, it looks like 3 inputs. Sorry. Yeah, 3 inputs and then 4 outputs. If I did that right, because you have to look at the. It's kind of hard to visualize, and my brain's kind of like still trying to enumerate everything, but it is and it doesn't make any sense to me, but I would have to like draw it on a board, because it wouldn't make any sense for me to explain it like this, because you can't really see what's in my head. So it's kind of hard to explain without there being a board or a diagram of some sort. So people I mean, like, this is just how I see it and whatnot. I'm simplifying by one dimension, but it seems to have that trend of two. I'm just making sure I'm doing this right. Is it 3n? Yeah, it's 2n and then 2n plus 1, I believe. And I think it was something like that. Or is it 2n plus 1 and 2n plus 2? I think it's 2n plus 1, 2n plus 2. You have to do 2n plus 2, or you then can distribute the 2 out, and then 2 times n plus 1, and you still get a. But then you get a 2n plus 1. But yeah, I mean, the 2n plus 1, again, it's 1, and then the 3 sides, of course, that's for the inputs. You get a 2n plus 1, and then the outputs is a 2n times, or 2 times n plus 1. And the n plus 1 is in parentheses and whatnot. Anyways, yeah, that's just a lot of math stuff, and it's probably right. It looks like that's a pattern, but I don't feel like thinking about it right now, because I could write it on a board and it would make more sense in my head if I did that, but I haven't written it down yet. I'm just trying to visualize all of this information. It's kind of, I don't know, I don't feel like doing, computation is fun, but I just, again, like, I'm kind of out of practice with math, and then I had to like think about it multiple times, even know if I'm doing right in my head. And yeah, so it's just like I haven't been practicing math. I've been more interested in other things, and more applicable things, I guess. And again, numbers are good, and of course for measurement and all that. But I'm not measuring anything. I'm just coming up with a framework, right? Yeah. I also I didn't subscribe. I made an account for the Institute of Electrical and Electronics Engineers, I believe. Yeah, Electrical and Electronics Engineers. It's IEEE. It's a weird acronym, but it is a thing, and they have a lot of interesting new stuff pertaining to technology, and I happen to be interested in technology, so I look at that sometimes. What was it? The IE spectrum. Yeah. A lot of interesting articles. I mean, I just like reading. I just like reading about anything pertaining to anything technical, even more complicated things like biology and chemistry. I want to acquaint myself with those things more, so I can appreciate the building blocks of the universe from that perspective, at least seeing it from a more complex point of view. But I'm not sure if I want to do that anytime soon, because I still have a lot of other stuff that I'm learning, and yeah, I have a actual project that I have to work on with my brother. So an actual project. That's going to be fun. I haven't programmed in a long time, so I have to get myself acquainted with at least the basics of Golang, and it seems pretty straightforward. But oh, I see. That's what import FMT is. Okay, FMT just happens to be a carrier format functions, I guess. Like println or FMT may just be like that may just be IO stuff pertaining to the display screen on a terminal. I don't know. Maybe that's how they distinguish it. Where did it go? Oh, there it is. Where's FMT? Oh, encoding is under package encoding. Textual represent. Okay, so they have encoding. Okay. That's all under encoding. You have FNT, but I thought I used a different package. Why is it? It's called package main. Where's main at? Oh, it must be the standard library, so it's all under that, and FMT happens to be under encoding. Okay. Oh, they have IO stuff, packages. FS. Oh, file system, FS. Input, out, utility functions. It's a lot of learning. Yeah, so I had to learn Golang, sorry. I think it was developed by some Google engineer. Golang is used in Google, I think. Oh, it's also statically typed. So you have to, statically just means that you have to actually be very specific about the variables that you're naming. Like, I don't know, like, again, you can think of it from a mathematical perspective, you can think of it like as a computer science perspective, like, I don't know, like integers, you know, if you name something as an integer, it stays as an integer and doesn't change. It's like C. It's a high-level general-purpose programming language. High level. You have to keep that in mind, which makes sense because it's dealing with structures, a lot of structures that are kind of abstracted by these languages. Like, it's not like C in that sense, but you know, at least I'm not sure. I think I like static. I don't know. I've always used statically typed languages. That's just always like the language that I use when it comes to computer programming. Yep, it was designed in Google 2009 by Robert Griesemer, Rob Pike, and Ken Thompson. Ken Thompson was also a part of this. That's interesting. Remember him? Wasn't he with Bell Labs, or is that somebody else? Yeah, he's really old. Didn't he work in Bell Labs? Yeah, he worked in Bell Labs. Yeah, that's cool. I didn't know Ken Thompson was a part of this project. That makes sense on why it's kind of influenced by C to some degree, with the curly braces and it being statically typed, and probably a lot of lingo that pertains to C language. Yeah, so what I'm trying to remember, like how C. No, it's basically the same even when it comes to functions under libraries and whatnot, kind of. And they call it func though. They don't do that in C. They don't say func in C. Usually, yeah, when you're naming a function, you just have to put the integer that it outputs, or the type that it's outputting. So that's also interesting. It just says func. But this is also main, so maybe, again, this is a high-level language, so I think it already knows when you have main in there, it knows that it's outputting probably some error code of some sort that's an integer. Also, if you're specific about it, maybe there's a way to be specific about what is outputting to the console, but I don't know. I don't know yet because I still have to look into that. But yeah, I mean, that's what else have I been looking at? I'm trying to slow down a little bit because again, I'm kind of like going everywhere at once, and So I need to implement a new schedule for myself, and of course the schedule is going to be modified when I get a job and all that, because that's going to be even more for me to have to withhold holding a job and doing all these projects simultaneously. So yeah, I have a lot of stuff I need to do. I was also looking at the documentation, aside from like the standard library stuff. I went through the getting started. I didn't go through the create a module, so maybe I'll do that next. The multi-module workspaces. Okay. Yeah, there's a lot of stuff. I don't even know what RESTful is. I don't know what Gin is. Gin is something. It's another language. Oh, it's the Gin web framework, some kind of framework. Generics. And fuzzing. Yeah, I don't really know most of this stuff. So, what is fuzzing? Oh, generate inputs to your tests that can catch edge cases and security issues that may have. Oh, that's why they call it fuzzing. It kind of makes sense in my head. When you think of something being fuzzy, it's like a lot of little prickles, but edge cases tend to be kind of not seemingly insignificant, but hard to find at times. So maybe that's why they call it fuzzing. And fuzz testing or fuzzing is an automated software testing method that injects invalid, malformed, or unexpected inputs into a system to reveal software vulnerabilities. Yeah, it's just a testing. Software testing is always fun. Don't they have stuff called like unit testing? I remember learning about that in Programming 102 or something. So I took a second course in college about testing in Python, but it's funny because in the exam they didn't ask us about testing because I don't know. It was just something that they kind of just breezed through and whatnot, which is cool, I guess. I don't know. I haven't done a big enough project to really require testing. So yeah. What else? Do I have anything else I need to do? I'm gonna go grocery shopping today, and I'm gonna look more at Golang today, and maybe I'll like kind of split 2 and 2, like 2 hours of Golang practice, and then I'm gonna look more into physics stuff. Again, I think the physics stuff that I've been mainly focusing on. I did look at the Pauli exclusion principle. It was something I didn't really. I'm sure you can find this stuff in a Quantum Mechanics 101 book, but I am actually getting one in a few days because my dad is bringing me a box full of my books that I used to have over at home. So that's nice. I don't know, like, I still have to look at the Hermitian stuff, and yeah. I guess I'll look at harmonic oscillator and how they're mathematically divided, because I forgot how they devise it in the standard way, at least. They say it as like, like the standard one is like a spring with a negative kx, and then, there's an amplitude and all that, and you can find the amplitude by finding, it's a good way to think of that, like the total energy can be found through the amplitude as long as you know the force, of course. And or then I guess the total energy can be stored in that spring. So I guess so it matters what the tension force is and whatnot, and how much information how much energy can be stored by how much you stretch it. But if you think about it normal and you're not thinking about I guess you can think of an external force being applied to it. So it depends on the force and all that too. So. Until it reaches equilibrium. So that force applied to a spring, or that mass tied to a spring, is just equal to that. And you can do some quick math. So if I remember correctly, energy is nothing more than the difference of work. So the work applied to 0 is obviously 0, and then you just had to find the work done at the end, the final work done, which is f dot dx, and you just have to do it the dx times f, and the dx can actually be found through the relation between f dot negative kx. There's a direct correlation between that. So I guess it would just be negative kx times dx, and dx is nothing more than the kx, negative kx squared. I remember seeing that actually it was negative kx squared. I just read to write that without even, yeah, it was negative kx squared. I'm just trying to get back to my mechanics days, I guess. But it's hard to, like, I don't know, for me, it's just I'm holding so much information in my head, it takes my brain a second to remember or to get back into the context of it, you know, because I'm looking at multiple contexts at once, and then task switching, I guess that's a form of task switching. It's like, oh, I just put this into my working memory to then, you know, create this or whatever, I don't know. Yeah. Computer, I mean, it's not much task switching because, you know, computer science and physics have a lot of parallels, of course, and whatnot, so it's not horrible or anything like that, but, you know, it's still a lot for most minds to wrap their head around this stuff, and I'm tired because I'm not just doing that. I'm just hoping I can actually just keep this information in my head. But yeah, I'm excited to get I can't wait to get my JLabs. Yeah, and they're better quality JLabs too, so I'm excited for that. And I'm just gonna, yeah. Anyways, I've talked about what I was gonna do today, which is, you know, Golang, and I'm gonna keep doing physics research pertaining to. I think I'm gonna do Hermitian matrices. I'm gonna actually write down a list of things I want to understand by the end of a couple of days, at least. Hermitian matrices. And I want to still get into topology a little bit more, and I was also studying tensors. Oh yeah, I was looking at the Ricci curvature tensor, so I have to look at that. I'm probably going to look at that today. That's another thing I need to wrap my head around, because I did the metric tensor already. The metric tensor is kind of easy. They gave, I found a video that gave a good analogy for what the metric tensor is. It's nothing more than like, it's a transformation matrix, essentially. You're transforming from one coordinate to another, basically, and you can do scaling, and then there's also, like, you can change the angle as well, so you can, like, I guess, squashing in particular directions, and it encodes all that information. But, you know, if you're looking at a 2D plane, sort of 2D planes, it's like a plane embedded in 3D. This would be a two-dimensional square 2x2 matrix, and I think how they do it is that the diagonals are the information containing the x squashing factor, squashing set stretching factor, and then the y squashing set stretching factor. If you look at it that way, and you're going down a line and whatnot, as opposed to like going. I mean, of course, if it depends on the angle that you're going then in 3 dimensions, but in 2 dimensions, that's basically what it is. Yeah. So. They used topography kind of analogy for it, which is cool to see. Yeah, and then the other angle that's going the other way is for the angle change, basically. It's not just, you know, there's not just squashing. You can rotate it in different ways. Like, I don't know, it's like it's not just doing this, but you can, I guess, shear it. If you take a 2D space, you can not just squash it, but, you know, you can shear it in multiple directions. That means the coordinates will change like this. Both x and y, they'll go at an angle, and that's how you modify it. If you look at a base, I think that's actually a good idea to think of it as. Just think of it as a basis vector and what you can do to it inside a 2-dimensional space, right? You can squash it, you can stretch it. Of course, we're looking at 2 basis vectors, but you can squash it, you can stretch it. That's already 2 bits of information. Then you have to look at the other one, which is also squashing and stretching. But this squashing and stretching factor is actually encoded. It can be negative or positive, right? So that'll be encoded in 1, and then the other factor will also be, you know, y will be in another dimension. But I don't know why they have it in diagonals. I guess as information pertaining to X, and then information pertaining to Y, so X, and then everything pertaining to the transformations that are induced on X is in one column, and then the transformations that are induced on Y is on another column, probably. So yeah, and anyways, like I was saying, so if you look at the X column, which is a basis vector, you can squash it or stretch it. That's one component of the matrix or tensor. And then the other one is rotating in one direction or the other. That can be positive or negative. So these are both real numbers. And then it's the same thing with y's. They're both real numbers as well. So that wasn't a great explanation, but it makes sense. And I didn't think about it as I was explaining it, because I actually didn't know until I started explaining it. So actually being able to explain things is nice. It makes me understand it a lot more. So that's a very simple explanation. And now is this a rectangle? Now that I think of it, I think it's it's not square. I don't think it's always square, because you look at another dimension, you're just going to be looking at the oh, I see, because like if you look at it's still square, because if you add a new dimension, a new basis vector, this means we have 3 dimensions, and then you have to look at the basis vector embedded in 3 dimensions. Of course, you can squash and stretch it. That's the next one. Then the next one would be rotating it along a axis, and then it's not just that axis. It only reaches certain points. If that kind of makes sense, you'd have to think about all possible permutations, which means you would have to look at a perpendicular axis. So it would be going this way, and then you'd have to look at it going this way as well. So if you take all of those permutations, and it'll expand through all of space in that way, if that makes sense. And then that'll obviously be 3, 3, and 3. So that means it stays square. So this the metric tensor stays square. It's good to know. So now what else do I have to do? I think that's all I have to, that's all I've been thinking for now, and then I'll probably look at again, I'm kind of going everywhere. I'm looking at general relativity, but I want to have a good fundamental basis of GR and quantum mechanics before I get into anything more complex than that, because they're essentials, and I just that's the essentials of understanding more modern physics. So I can't quite run away from it. So I'm tired. I'm just tired. My head's just constantly running, and I can't stop it. Even though I'm tired, it keeps running. It's annoying, which is why I take naps. That's the only way I can actually turn off my head, is by, I usually throw on meditative music and just blast in my headphones. I really hope I get that job over the park, because that'll make my situation a lot easier. They said they'd hire me in a month or so. And that's, I do have quite a bit of padding for I don't want to be specific, but I do have quite a bit of padding, so I'm not really too concerned about my job search, but at the same time, I would like a job. And I'm also getting income from my UI, and I'm also getting SNAP benefits, so that'll probably, help out with the padding a lot more, especially with, depending on how much they pay. They pay me bi-weekly, but oh shit, man, I have so much to do, man. That's why I just don't like thinking about it. I just have to start doing it, you know what I mean? I just had to start doing it. So I was a little bit lazy yesterday because it was Sunday, and also Saturday. It was Saturday, so I just like to have my weekends as my excuse for being a little bit lazy. I like to have my days off, and I guess it's Saturdays and Sundays. It's like my relaxed days. Is this a holiday? Is it a federal holiday? I don't know what federal holiday it is, but yeah, I think I saw that on one of the websites. So Yeah, so that's another thing. It's a federal holiday today, so I don't want to be too crazy about everything. Yeah. So again, I'm not trying to burn myself out. It can happen with me pretty easily if I don't regulate my mind and my body. Anyways, I think I'm done for today. Done talking. I hope you guys have a good one. Bye.